Industrial Technologies in Gila-Lilia-based university. So, Professor Amar, you're welcome.
Thank you very much. Do you have is it correct my sharing of the screen?
Yes, we
Yeah,
can
it is
see
perfect.
It's okay.
Yeah.
okay.
Okay, I can start now. Okay, dear students, so I am happy today to be with you, and I will, in spite of my bad English, I will try to do my best to present you the main activities of our laboratory, APELEC Laboratory, Application of Plasma, Electrostatics, and Electromagnetic Compatibility. It's in the University of Sidi Belad, Algeria, and I am the director of the laboratory. I will talk you about experimental activities in this presentation. So I will start with electrostatic separators of particles to separate different type of mixture of particles for recycling industry, for example. I will talk another technique you will understand more after called traveling wave conveyor, and after I will speak about the electric barrier discharge that is used to generate as a principle of ozone generators for generation of ozone for water treatment and disinfection and sterilization. And if I have enough time, I will talk about the last activity, which is the Pulsat electric fields. So I will start with electrostatic separators of particles. The electrostatic separation is a technique used to separate a mixture of particles that of size lying between 0.1 millimeter to 5 millimeter. It's a mixture of, let's say, for example, metal and plastic particles, in which application can be used this technique in the recycling industry, for example, to recover waste, industrial waste, or in mining industry. There are two types of electrostatic separator. Separator for separation of metal plastic particles, and other one Triboelectric separators used to separate plastic different particles. For the first separator, its main application, typical application, is the recycling of electrical cable wastes or printed board, electronic printed board PCB wastes. This is so the wastes are crushed in particles and then separated, like you see here. We obtain pure copper and pure plastic. The principle working principle of separator, I am not going to give you so much technical details because you need electrical engineering background. So simply there is a rotating roll and a vibrator feeder that deposit the particles on the rotating roll. There are high voltage electrodes. The plastic particles get an electric charge and they are so pinned, attached to the cylinder, and they are recovered at the left, because below there is a collector of the compartment. So the plastic particles are collected at the left. There is a brush to remove the attached particles of plastic, while the metal particles are ejected by the centrifugal force. So here there is an intense electric field that is the cause of the separation. If there are questions, I can answer after. This is a photo of the action of this separator. We have at right the plastic particles that are strongly attached to the rotating roll, and at left we have the metal particles trajectories. You see, they are ejected by centrifugal force, and they are the plastic particles trajectories that are removed by the brush at the left. Here is the laboratory prototype that it was developed in 2004. We can see the main components: the vibratory feeder, rotating roll, high voltage electrode, and the compartment and the collector with 3 compartments. This is an industrial prototype that was developed by our laboratory in 2018. It was delivered to a national company here in Algeria, Entreprise Nationale de Récupération in Oran. It is still now used for recovery of electrical cable wastes. This machine was sent for the firm for this amount in Algerian dinar, equivalent let's say 20,000 euros. The other type of separators that can be used in Algeria or in African countries is for the recovery of plastic wastes. Here, just a little number. In 2006, there was 10 PC in the world recycled. So the amount of plastic to be recycled is huge. This type of separator is called Triboelectric separator. What is triboelectricity? Triboelectricity is the first electrical phenomenon known by the human. It's when you take two objects and you rub the two objects one against the other. One object will get a positive charge and the other object will get a negative charge. It's tribo in Latin means rubbing. So when rubbing two components, two materials, or when entering in contact, simply they get opposite charge. One gets positive charge, other gets a negative charge. Here, an example on one of the several separators that we have developed. Simply to explain you, we have a mixture of plastic particles. It is introduced in a rotating cylinder. Inside the cylinder, the particles are, there are several collisions between the particles themselves and with the rotating cylinder. At the end, at the output of the cylinder, they fall, and each type of plastic would get a precise charge. One type would get a positive charge, and the other type of plastic will get a negative charge. They fall down in it's a free fall. They fall down between two high voltage electrodes. They are square electrodes. Here we apply a voltage of nearly, let's say, 60 kilovolts, 60,000 volts, just an electric field with no current. And the particles that are positively charged are attracted to the negative electrode, and vice versa. The particles that are negatively charged that are attracted to the positive electron, and below there is a collecting boxes to recover each type of plastic. Here there is a video to show you different separators. If we have time at the end of the presentation, I will show you this video. It lasts 5 minutes, so I prefer to pass it, and if you want after, I can show it to you. The second activity that we develop in the laboratory, and that are all activities that are feasible and can be easily developed in Algeria and the African countries. The second activity is the traveling wave conveyor. This activity is the traveling wave technique is a technique used to cause the movement of fine particles, mainly to cause the movement of fine particles. In fact, it's constituted of parallel electrodes fixed on an insulating support with an inter-electrode gap between the electrodes of 1 to 2 millimeters. The applied voltage here is nearly 2 kilowatts, 2,000 volts. And it's electrical voltage. There is what we call phase shift between the voltages, and following this, there are two applications. The first application that can be used in the traveling wave technique is a dielectric, what we call a dielectric force that causes the movement of fine particles. The second application is an attraction force that is applied on metal particles. To explain you more this without give you more technical details, I will show a short video here for the first application that causes the displacement or the movement of particles. Here we have an amount of particles, PVC particles, that can be sand particles, that can be sand particles. So simply, here there is no vibration, just an electric force. Where can we apply this? We can apply this, for example, for self-cleaning of DC surfaces in PV panels. We have currently a research project to cause to do the self-cleaning of dusty surfaces of PV panels. The second application of the conveyor technique is the separation of metal plastic particles. We observed it in our laboratory. It was observed for the first time in our laboratory that with this conveyor, the metal particles are attracted to the conveyor. There is an attraction force applied only on the metal particles. This is patented in our country. So when we put this conveyor on the vibrating plate, we see that the plastic particles are displaced, are by the vibration. It's a mechanical vibration. The conveyor is put on a mechanical vibration, but the metal particles are pinned on the surface of the conveyor. So there is a separation. There is a new separation technique that is used in our, so it can be applied as industrial prototype. So I give only the main information without technical information. The third application that we have developed in our laboratory, and we have focused mainly this year to fight against COVID-19 pandemic, is ozone generators. Ozone generators are developed, are functioning on what we say, we in electrical engineering, dielectric barrier discharge. It's a plasma. This plasma generates ozone. Ozone is used mainly for water treatment and is used also for disinfection and sterilization of air. The dielectric barrier discharge is an electric discharge between two electrodes. When you introduce a dielectric barrier, the breakdown between the electrodes is continuous. In this way, we don't have high values of current. I don't want to really, so I just the most important information. So there is a plasma between the electrodes. This plasma between the electrodes allows to convert the oxygen. When there is oxygen flowing between electrodes, the oxygen O2 is converted in ozone O3. So the ozone is an unstable gas. The molecule of oxygen is dissociated in two atoms of oxygen. The singular atom is coupled with the molecule of oxygen, so it forms a trio of three particles of atom, that is ozone. The ozone is unstable. When it enters in contact with a bacteria or a virus, it oxidizes it immediately. It's the most fast oxidizing mean to fight against viruses and bacteria. Its main advantage also is that this gas is unstable. After 30 minutes, 1 hour, the ozone is reconverted to oxygen. So there is no byproducts after this disinfection operation. This is used for water treatment and for disinfection sterilization. I am not going to focus on water treatment because I don't have so much time. So I focus on two applications. The first is to irrigate plants in agriculture with ozonated water. We tried this in our laboratory with tomatoes. So we took five so with tomatoes, in 5 it was controlled. It was irrigated with normal water, and 5 other it was irrigated with ozonated water. And we was really very satisfactory to see that the ones irrigated with ozonated water was really development. The evolution was very fast, and we get more amount of tomatoes. This was proposed to an industrial agricultural group here in Sidi Bel Abbas, now in Algeria, Group Hasnawi, and now this technique is tried. It's currently in work in progress in a greenhouse in Sidi Bel Abbas to test this irrigation with ozonated water in a large scale, and if the test started just this week. We will have more information after 1 or 2 months, inshallah. So we hope that we will have nice results, and it's a nice technique to improve the agriculture. The other application of ozone generators that we developed during this pandemic, this year, with our team, my team of so we developed 3 ozone generators. We call them 30G, 60G, and other one is a medical sterilizer for medical device. I will talk about that after. So the 30G and 60G ozone generators were developed by our laboratory to a national firm, a national company in Tlemcen. It's called Soremap. Soremap is a national company, is now manufacturing these ozone generators and is now commercializing them in Algeria to fight the COVID pandemic and also for normal disinfections. These used to disinfect spaces like ambulances, cars, rooms in hospitals, rooms of meetings, any rooms, any space where we need to disinfect them. The prices are shown here. For the 30G, it's about in euros 200 euros, and the 60G is about 400 euros. These models were sent a month ago to Europe to get certification to export them to Europe. These devices are really very easy and can be built in African country. I can help any young or any student who want to start up with this activity. Another device that we have developed during COVID pandemic is the cabin disinfection for people. Like you see, it's a cabin well sealed, where the person enters inside. Inside there is a ozone generation system, so the person enters inside and then close the door. And it's also patented this in June 2020. And then the person lasts in the cabin for let's say 5 minutes, and after the person is totally disinfected. We have done bacteriological analysis of this on total flora. So the person has entered inside the cabin, and we took samples from the air, samples from the hand of the person, and samples from the cloth of the person. And we do bacteriological analysis were achieved, and you see here very nice results. Before is before, so before treatment, after treatment only. Before we had a lot of many colonies. After treatment, 1, 2, 3 colonies only. So it's very efficient. Another project of this that is in progress, ongoing project with the national company here in Sidi Bel Abbas, Uni. It's a company of electronic industry. This is in progress. This is like cabin for people, but it is a chamber of sterilization of, let's say, 5 meter cube, volume of 5 meter. So in this chamber we have so the étagères, you can say this in English, and the ozone generator inside, and this mobile chariot that we can put inside the chamber, and we cross. Inside there is a generation of ozone, an ozone generation system, and of course there is a system to destruction of ozone after operation, because ozone before to open the door, it must be destructed inside. This is also patent in progress. So we made also analysis of this about this sterilization chamber on many bacteria. This is an example for Staphylococcus bacteria that is well known, and you see before treatment, lot of bacteria. After 30 seconds, 1 minute, 1 minute 30, 2 minutes, and after 2 minutes 30 seconds, no bacteria. It's sterile. This bottle of Petri. It's very sterile and very nice results. And this project is, as I told, in progress with a national company. Well, do I have enough time? Hello?
Yes, Professor. We have quite some time, but of course, you can still have some few minutes to round off your presentation, after which you can now show the video, which you talked about earlier.
Okay, okay, 1 minute for the last activity and then the video, which will take 3-4 minutes. It's okay?
Okay, Professor, that will be fine.
Thank you. The last activity is what we call pulsed electric field. This is used, what we know, you notice better in my presentation, that we use high voltage levels. So 1 kilovolt to 50 kilovolts, depending on the application. The pulsed electric field, without giving technical details, it's you see here in square. A square, it's a short. We applied a short high voltage electric field during microseconds only. Why do we apply this during microseconds? To produce what we call electroporation of biological cell. When we have an electric field enough strong, so the cell membrane is stressed, and when it is stressed with electric field, there are pores here. You see. If the electric field is not strong, nothing has nothing. There is nothing. If the electric field is strong, there is pores here, like small doors here, and these pores, what we call electroporation. So in this way, what is inside the cell will be easily extracted outside. We apply these for extraction. There are several applications of these. It's to improve to intensification of the extraction amount of liquids, of, for example, juices, and we used it to improve, to increase the amount of essential oils. You know, essential oil is very expensive. So this is a plant from Mascara, not far from Sidi Bel Abbas. It's called Marubu. We applied electric field 0.8, 1.6, 2.5, and without PF, without pulsed electric field. We see that when we use electric field, the amount of essential oils is much higher. This is another example. I pass this. This is an example. So here we apply electric field at the left here. Amount of juice of apple and the beetroot without left without pulsed electric field, at the right with pulsed electric field. We see the la pâte, you see the pate and the mesh. You see when we use PF, pulsed electric field, it's very dry. It's very dried. It means that all the juice was extracted. Thanks for attention. Just a little moment. If you, I have 2 minutes. The last video. Okay, this one. This is different separators. I will. Problem of. Excuse me. Okay, apologies. Do you see?
For me, not yet. Hello, Delise, can you see? I don't know, maybe.
I don't know if you hear me.
Yes, we can hear you, Professor.
So here the first separator for object is that second one, separator of plastic particles. This is a mixture of plastic particles we put inside the. Here there we have two discs inside. Also, I pass this up. Is put inside. There's two rotating discs. Each disc is connected to a high voltage power supply, and there is an ejection of air in below. So after we have separation, because each type of plastic will get one positive charge and other negative charge, and they are after they are separated. This is the first to the time I pass. If you want more details, I will let you my others. This is another separator. What I showed in this rotating cylinder, we put inside the mixture of our plastic particles. They are charged inside the cylinder, and at the at the input of the output of the cylinder, they are charged, and they fall down in free fall between two high voltage electrodes. And here you can see the separation by colors. Here green and here blue. The third one is metal plastic particle. This for recycling, for example, electric cables. This is a mixture of metal plastic particles. We put these on the vibratory feeder. This is high voltage power supply, 20 kilovolt. The vibratory feeder is put on and the rotating cylinder. And after the metal particle, as I told before, they are ejected, and the plastic particle, they are pinned to the rotating cylinder. So we have a separation. See that here. So here plastic. This right one is for the metal particles, and in the other compartment we will have the plastic particles. Okay, thank you very much. That's okay, sir.
All right. Thank you, Professor. Thank you, Professor Amar, for your very interesting presentation. So now we are going to address some questions that have been asked by the fellow students. And our first questions goes to Schneider Electric. So,
Julie, can I interrupt you a little?
Yes.
Okay, please. Sorry about this, but our presenter from Schneider Electric has an urgent meeting, and he just stepped out. So he has left his contact with us. And if you have any question that has to do with Schneider Electric, of course you read it out, but we'll communicate to them directly and they'll respond to us via mail. So if the question is addressed to the Schneider Electric directly, maybe you can skip it for now and we'll send it directly to them with the answer, because they are no longer in the meeting now. Thank you.
All right, it's okay. But then we shall, our next question goes to Professor Amar. We were seeing a number of technologies, and people want to know, while taking into consideration the water energy food nexus concept, does water professionals like water engineers or water policy makers or analysts have a place in that environment of improving technologies and in energy sector?
It's a question for me?
Yes, sir.
Sorry, I didn't understand the meaning of the question. Do you want me to speak about the policy of water treatment, or about the technology processes that I have shown?
The question is, we have seen a number of technologies that can be applied in a number of fields, like in environmental management, like recycling waste and all those things. that can lead into production of energy. But then taking into consideration the water energy food nexus concept, do water professionals have a place in that field?
Okay, you speak about users in water professionals to use these techniques. Okay.
Yes.
I talked about different parts. There is a part for water professionals. A nice part for water professionals is about the treatment with ozone treatment. With instead to use chlor, now ozone is widely used to disinfect water. So there are two parts. The first part is to develop a system based on ozone generators to disinfect water. Nowadays, for example, in wastewater in developing countries, the disinfection with chlor is forbidden, and it's now more people go to the ozone disinfection. So we can use ozone to disinfect water in any there are many types of water, drinking water, wastewater, in swimming pool. For example, now for the Olympic Games, the swimming pool should be disinfected by ozone, not by chlor. The other part of ozone in water is to use the ozonated water. What is ozonated water? It's a water that is mixed with some amount of ozone gas. And ozone gas is injected in the water. So the water became ozonated, what we call ozonated water. The ozonated water is what I show in the slide. For example, if we irrigate with ozonated water, it's more efficient than normal water, first. Second, we can try to use it as a pesticide. We say this in English, pesticide, chemical pesticide. Instead of chemical pesticide, we can use only ozonated water, which is cheap and more pure, because there is no chemical products used in this technique. So there are, to resume, there are ozonated water for irrigation, and there is ozonated water that we can use as pesticide to pulverize in trees and the leaves of trees to fight against insects. Thank you. Thank you.
All right, thank you, sir, for your answer.
So, Delis, from your side, do you have any further questions?
No. For all the other question goes to the person who is not around, and we shall try to get answers later. Thank you.
Okay. While we still hope there will be more questions from our guests, we'll ask some questions. These questions are general to all the speakers, so anybody can give us answers based on their presentations and their organization. First of all, provision for the question is there provision for topics and research supervision for students who wish to intern with your organization? So we expect to get answers from Professor Keller, Professor Amar Tilmatine, and of course, we'll get across the speakers from the company Triboelectric to give us responses. So Professor Amar, since you are here with us, can you give us an answer, please?
I think for this question, because I don't teach in the Pan-African University. I am from Sidi Bel Abbas, so I think that another person is more suitable.
No, the question is, since is your organization positioned to provide internship placements for PAUWES students, for their research master thesis? And if yes, does your organization provide maybe research topics and supervision for the master thesis? Or can students come with their topics and intern with you while you provide them the resources for their research?
So if I understand well the question, the students are very welcome to contact me for anything, for any process that I have talked about. You can give them my email, and I will help them everywhere in their country to develop these techniques. For the master, you asked me for the master. Academic master learning here in the university. No?
Yes, I am talking about, earlier Dr. Amazik talked about master thesis research internship. That is in a few months from now, the students in PAUWES will be going for an internship for their master thesis. Okay. And of course, all of us are looking for places we can do for our internship. That's for organizations, maybe institutions or companies. Yeah, and yes, and we are wondering if your organization can provide internship placement and maybe supervision for research internships as well as topics in your areas of specialty.
Yes, they are welcome. If they want by internet, if they want to come to Algeria to see the Abbas, they are welcome. We can find some organization to welcome them. No problem for me.
All right, thank you. Professor Abdullah Kelas, would like to hear from you on this question, please. Professor Abdullah Kelas, your microphone is muted. Could you, if you're there, could you unmute and give us a response, please?
Can you hear me?
Yes, we can hear you now. Thank you.
Okay, thank you. I'm sorry. So as I said, I have been with PAUWES for a long time now. And as I said, also since we are dealing with subjects that are of high interest to the students. So please feel free anytime you have any question on CDR or things related to contact me. I think Professor Zerga has my phone number. Professor Sharif has my number. My friend Amazir, I say hello to him, he knows me. And so Mr. Mohammadi, who is with you, also has my number, and I would be more than glad to answer any question or to help any way I can.
Okay, thank you so much. For now, from my side, I don't seem to get any further questions. But of course, I don't know, Delis, if you have any questions or any remarks for our presenters before we go to the closing remarks.
Yes. Thank you to the speakers of the day. This was a very interesting and educative sessions. I hope that we've learned a lot, and we are looking forward to what